All right, we're continuing on with the standard. Not sure why that's doing that. In section 2.5, graphing different linear function, step functions, integer, greatest integer functions, and absolute value functions. We haven't got to that part yet, but that's okay. All right, so here I've been given a piecewise function, and we're asked to graph it and identify the domain and the range. And so I have to come up here and actually put my X and Y on top of that. Domain, D comes first, R comes second, then I have my X and my Y. That's how I remember it. All right, so I have a value of X, for all the values of X less than or equal to -2, I have an output of 1. And so here is 1, and I come up to -2, and I have to have a closed circle because of the equality. Where is my paper so I can make sure? Yeah, that's it. Okay, next one. X is greater than 2. I have an equation of a line. So here's my equation of a line, y equals x plus 3. And I have already shown a data point at the y-intercept of x is 0, y equals 3. And I have a slope of 1. So I will draw my graph like this. And it is an open circle because it's greater than -2. Then I have to ask the question, what are all my possible domains? What is all my possible X values? And even though the first piecewise function does not, I'm sorry, the second piecewise function does not include -2, the first one does. So that takes care of -2, and that's all reals. And hopefully you see that the Y values for this piecewise function are greater than or equal to 1. I can only have values in this region all the way down to 1. Okay, all right, moving on. So I have in the area of X is less than 3. I have the equation of -x plus 1. So here's a trick. Take the 3, plug it into this equation. -3 plus 1 equals -2. So that's where everything starts, 3, -2. So I go to a +3, go to my -2, and I have to decide, is that a whole open circle or closed? And because it does not have an equality, it is closed. Okay. Now it has a slope of -1. So I've got to go up 1 over 1 to the left or down 1 over 1 to the right. But somewhere I have to take care of that negative. So I'll go up 1 over 1, up 1 over 1, up 1 over 1. And that's what it'll look like. So I've taken care of that function. Next one, x is greater than 3. I have the equation of 2x minus 4. So take your 3, plug it in there, get your data point on your boundary condition. So I get 6 minus 4, which gives me a y value of 2. So now I have 3, 2. I've got to go find my first point that I want to start evaluating. So x is 3. We'll do this one in green. X is 3, y is 2. And then I have to decide, oh, it has to have an open circle because it's not an equality. And now I have a positive slope of 2, up 2 over 1, up 2 over 1, and I would draw something like that. And now I have to answer the question, what are all my domains and my ranges? Well, hopefully you see that we have a hole at 3. At x, there is no value on this piecewise function at x is equal to 3. So you would write x doesn't equal 3. Every other value, we're good. What about y? So now I'm looking at this graph in this kind of this way. I come down and I go to -2 and I can't have anything less than -2. Does not include -2, so y is greater than -2. Well, yeah, okay, moving on. X is less than or equal to -3. So what is my y value? What are my outputs at that point? I have a 4. So everything less than -3 all the way up to it, and it's got an equality, so I have a closed circle. Okay. All right, next one, -3 up to +2. I have a y value of 2, and does not include -2. I'm sorry, -3. It does not include +2. So I look something like that. Third one, x is greater than 2. Y is -1. So go down to -1. It does include +2 because it says equality, and I move off to the right. Now, what are my domains and my range? Well, x, all right. Even though the second piecewise does not include -3 and 2, the first and the third do, so it covers it. So all reals. Y. Y's are only values of 4, 2, and -1. 4, 2, -1. Okay. Next one. X is less than -2. Go to the left. I have to have a y value of 2. Does not include -2. Looks like that. X is -2 all the way up to a +2. I have an equation of y equals x. So I have an intercept of 0 because b is 0, and I have a slope that is 1. So I want to value, I got to have a slope of 1. Oh yeah, that'll work. Why not? Up to a +2, because x can't be anything greater than 2, all the way down to a -2, because again, x can't go less than -2, and it's open circles because of the fact that there's no equality in this -2 less than x is less than 2. Okay. X is greater than 2. I have an output of -2. So I have no equality again. I have to have an open circle, and I move to the right. Now I have to figure out what are all my x's and what are all my y's. Well, what are all the x values? Hopefully you notice I have a hole here. X cannot be either positive or -2. What are all my y values? Well, now I'm going to look at the graph this way. It's only in these regions do I have an output value. So y, actually, -2 is less than or equal to y is less than or equal to 2. So y is in between -2 and 2. And it's an equality because it includes -2 and 2. Graph each function and identify domain and range. Same thing. We're having fun now. Alrighty, I have an equation. Now, this is my suggestion. Plug that in, find your boundary condition. So I have 2 times -2 plus 4, that gives me 0. So I have at -2, 0 is my first kind of boundary condition. So go to that location, -2, 0. Let me find that. There it is. There's my first point. Now I have a positive slope. Now the first thing you're going to want to do is go to your right, but you can't because you don't have allowed to have any x values. So you have to go to your left. It's just a line. You just have to draw the left side of the line. So with the +2 slope, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Okay. At x is -2, I have a value of -3. It's just a data point. For values greater than -2, I have another line. Take this -2, plug it into x, and find your data point that's at your boundary condition. negative, -2 minus 2. So 2 minus 2 is 0. So at the location of -2, 0, I have my first data point. Huh, that's right here again. I'm gonna do this one in green. I have a negative slope, a -1. So I'm gonna go down 1 over 1, down 1 over 1, down 1 over 1. And I'm gonna draw a line. And it'll look like that. Not done with the problem. I have to give my domains and my ranges. Well, I look across the x-axis and I see that I can go all the way to positive infinity, all the way down to negative infinity, and I see that I might have a hole at -2. However, the second part of the piecewise function that's highlighted in yellow includes a value for x at -2, so this will be all reals. Then I will notice that my y values that are possible are only approaching negative affinity and go all the way up to a maximum of 0, but doesn't include 0. So y is less than 0. All right, let's do the next one. I kind of wrote in a note here. So this is f of x. So y equals the integer, greatest integer value of x. So I got to evaluate that. So let's recall what the greatest integer value is, the greatest integer function. So what that is the largest integer that is less than or equal to the input value. So think about this for just a minute. What is an integer? Integer is a number that is not a fraction or has a decimal. So I'm going to look at all my x values that are an integer. So 1, 2, 3, 4, 5. And the output of that is the largest integer that is less than or equal to the input value. Well, if my input value is an integer, then it's equal to the largest value that it could be. So I'm going to have a dot. So for example, if my input is 1 and I plug it into this bracket right here and think to myself, is that value an integer? And the answer is yes, so my output is that. I don't have to go to the left on the number line, remember? So for 2, for example, I'm going to get the same thing. For -1, -2. Okay. Now, what happens? I forgot to add my 0, 0. What happens in between maybe 0 and 1? So let's think of a half. So what happens when x is equal to a half? Well, that is not an integer. So I have to then, on the number line, remember, I have to then have 0, I have 1, and I'm somewhere right there. I have to go to the left. I have to go to the left on the number line, and it's the integer that's less than that, right? So I have to go to the left one step. So it's the output, which is the y value, stays at 0 and continues to stay at 0 all the way until it hits 1. So I move all the way over with an open circle. And so that's what it looks like. And actually it would have been probably better. Let's pick between 1 and 2. So what if x was equal to 1.5? Well, on that number line, I'm right here. And I have to go back to 1 again. So all the way up to 1.99999, I still have to go drop back down to 1. So my y value, which is my output, stays at 1 until I hit 2 and I have an open circle, because then it jumps up to 2. And so here's the pattern. And once you figure out the pattern, you're good to go. Okay, now I have to answer the question, what are all my domains and what are all my ranges? Or what are all my output values? Domains are all reals. Every single x is included in that. In y's, not every y is included, all integers. I can't have a fraction or a decimal. Okay, let me spell it correctly. All right, let's do C. So we have f of x is equal to the greatest integer value of x divided by 2 plus 3. And the best way to do these types of graphs is to actually pick some values for x and determine what your output is, y, and then you can start to fill in some patterns. And once you know the pattern, you can you're good to go. Okay, so we need to pick some values of x. So I actually have shown over here, if for those of you who can't do this in your head, and I'm not the greatest at doing stuff in my head, to be honest with you, even when I was at my prime. I have values. Let's start with x equals 0. So if I plug in for x, the value of 0, so 0 divided by 2 is 0. I will, the greatest integer function of 0 is 0, because 0 is an integer. So 0 plus 3 is 3. So now I have this point of x is 0, and my output is the value of 3. Well, what about when x is 1? Well, if x is 1, I get 1 divided by 2. That's a fraction. I can't have a fraction as an output of a greatest integer value. I have to move left on the number line. So a half, I'm at a half. I got to move to the left, and that's 0. I come to my first integer to the left, and that is 0. And I take 0 plus 3 again, and bracket 3 again. Well, what happens when I take the value of x is equal to 2? Well, 2 divided by 2 is the 1, and that is an integer. So the output of that greatest integer function is 1. 1 plus 3 gives me 4. So I have just jumped up to 4. Okay. So I've just had a transition. So now it's a question of looking at the values in between. So if I have 1.5, so let's take 1.5 as x. Well, I take 1.5 divided by 2. That's still a fraction. That's less than 1, by the way. I move to 0, and I add 3 to it. So I'm still at 3. So it looks something like this, all the way up until I get to 2. And this one's going to do the same thing all the way up as I get to 4. Then this one's going to do the same thing all the way up until I get to 6. And this one's going to do the same thing. And then I have to go backwards, which is no fun. There it is. So I got my step ladder. Then I have to ask myself, what are all the possible values of x's? Well, even though I have open circles, the next step covers it. So I have all reals. And what about y? Once again, as before, all integers. Okay. Now we have another one. You can try it. My suggestion is to start picking some x values and plug it into this greatest integer function if you're not able to do it in your head. So pause the video and come back. So I have x is 0, x is 1, maybe x is 2. All right, so if I plug in 0, I get 2 times this greatest integer. What is the greatest integer of 0? It's 0, so I get 2 times 0 is 0. So at 0, my value is 1. Well, what happens when x is 1? The greatest integer output of 1 is 1. 1 times 2 is 2. 2 plus 1 is 3, and so forth. And what if it's 2? Well, 2 times 2 is an integer, so the output is 2. 2 times 2 is 4. Then I go to 5. And then I say, okay, what about a half? Well, if I'm at half, I have to drop back down to 0 again on the greatest integer output. And I multiply that times 2, I'm at 0 again. So it looks something like this. There we go. And I have to say, okay, what are all my outputs for, or what are all the possible X values? So what is my domain? It goes on forever and ever. And so it is all integers. Okay. And what are my range? We have all odd integers. I know those are tricky. Practice makes perfect. Take those homework assignments seriously and do what I think is probably required for most of us, which is create a little table. Okay. All right. That's what I got. Have a good day.